Alright, so in this problem, I have x to the power of x to the power of 3 is equal to 36. So, to solve this problem, I'm going to start by taking the power of 3 on both sides. So now I'm going to have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a. This is the same thing as a to the power of n to the power of n. So in this case, I have x to the power of x to the power of 3 to the power of 3, and we can think of x to the power of 3 here as m and 3 as n. So this is the same thing as a to the power of n to the power of n. So I can change the place of these two. So now this is the same thing as x to the power of 3 to the power of x to the power of 3. This is equal to still 36 to the power of 3. Now, 36 I can write as 6 to the power of 2. So now I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 2 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is also equal to a to the power of m times n. So 6 to the power of 2 to the power of 3, that's going to equal 6 to the power of 2 times 3, which is 6 to the power of 6. So now I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 6. Now I'm going to let x to the power of 3 equal to the variable y. So now I have y to the power of y is equal to 6 to the power of 6. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, y is equal to 6. So now I'm going to go ahead and clear up some space. So now I have y equals 6. However, remember that y is also equal to x to the power of 3. So now I have x to the power of 3 is equal to 6. So now to solve this, I'm going to take I'm going to take the cube root on both sides. So now I have the cube root of x to the power of 3 is equal to the cube root of 6. Now the cube root of x to the power of 3 is simply x, so I am left with x is equal to the cube root of 6. So this is my answer. Alright, so in this problem, I have x to the power of 4 minus 16 is equal to 0. So to solve this, I'm going to first rewrite x to the power of 4 as x to the power of 2 times 2. So now I have x to the power of 2 times 2 minus 4 to the power of 2 is equal to 0. I just simply rewrite 16 as 4 to the power of 2. Now, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So x to the power of 2 times 2, that's going to equal x to the power of 2 to the power of 2. And I have this minus 4 to the power of 2 is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to x to the power of 2, and b is equal to 4. So I have x to the power of 2 plus 4 times x to the power of 2 minus 4 is equal to 0. So now let me clear this up so I can make some more space. So I have x to the power of 2 plus 4 times x to the power of 2 minus 4 is equal to 0. So now this gives me two equations. I have x to the power of 2 plus 4 is equal to 0, and I have x to the power of 2 minus 4 is equal to 0. So, to solve x to the power of 2 plus 4 equals 0, I'm going to first start by subtracting 4 on both sides. So now I have x to the power of 2 is equal to negative 4. So now, to solve this, I'm going to take the square root on both sides. So I have the square root of x squared is equal to the square root of negative 4. Now, the square root of negative 4, that can be written first off, the square root of x squared is simply x, and the square root of negative 4, that can be written as the square root of 4 times the square root of negative 1. So now the square root of 4, that's simply equal to positive or negative 2, and the square root of negative 1 is actually equal to the imaginary number I. So I have x is equal to positive or negative 2i. So these are two solutions. Now for x squared minus 4 equals 0, to solve this, I'm going to simply add 4 on both sides. These two cancel out, and I'll have x squared is equal to 4. Now, if I take the square root on both sides, I have the square root of x squared is equal to the square root of 4. The square root of x squared is x, and the square root of 4 is equal to positive or negative 2. So my four solutions are x is equal to 2, x is equal to negative 2, x is equal to 2i, and x is equal to negative 2i. So this is my four solutions. Alright, so in this problem, I have x is equal to x over 2. So, to solve this problem, I'm going to first start by subtracting x over 2 on both sides. So then these two cancel out, and I'll be left with x minus x over 2 is equal to 0. Now, what I'm going to do is I'm going to multiply both sides by 2. So now I have 2 times x minus x over 2 is equal to 2 times 0. Now, 2 times x minus x over 2, to solve that, all I have to do is simply distribute the 2. So 2 times x, that's 2x, and 2 times negative x over 2, the 2 simply cancel out, so I'll simply just be left with negative x. So I have 2x minus x is equal to 2 times 0 is 0. Now 2x minus x is x, so I have x is equal to, what's left is 0. So this is my solution. Now another way of actually solving this problem is, let me actually erase all of this. So instead of actually subtracting x over 2 on both sides, I can simply just multiply 2 straight away. So now I have 2 times x is equal to 2 times x over 2. Now 2 times x is 2x, and 2 times x over 2, the 2 simply cancel out, so I'll simply just be left with x. Now if I subtract x on both sides, x minus x, these two cancel out, and 2x minus x is x, so I'm left with x is equal to x minus x is 0. So that's another way of solving this problem.